that that third variable has, okay? So this is how we're gonna run it. Very, very similar. Instead of clicking bivariate, we're going to partial. We are running a partial correlation, so we're gonna click partial. The first one's a bivariate, click bivariate. Just helps you remember where it is that you should be clicking. Variables of interest are going in your variables box. Control variables are going in your controlling for box. You should only be controlling for one variable. So make sure you guys read your question carefully. There should be hints as to what it is that you should be controlling for in that question. Your options box, just tick these two boxes here. Exclude cases list-wise to deal with your missing values. This is the output. So for the purpose of the assignment, you will notice that one thing is not on this output because that confidence interval box was not ticked off. When you do it, if you tick off the confidence interval box, it'll just give you CIs. So it'll literally say CIs for each of these relationships. CI stands for confidence intervals. It will give you the same similar range of values that you saw in your first assignment. So interpret those in line with how you interpreted your findings for last assignment, if that makes sense. Now when we're looking at the output, we have the top half of the table where it says none. So here, there's no control. This is basically the same as your first correlation. Doesn't mean that you don't run the first one because there may or may not be slight differences because as you guys know, as we rerun the same things, you're likely to inflate type 1 error and come out with things that aren't necessarily true. So could be the same, could be different. For the sake of your assignment and getting the right values, run a correlation, then run your partial. This is where you interpret for your partial correlation. Here you will see your control variable, which is physical fitness. When you guys walk over here, we'll see those same ones, and you'll still notice that weight and weight is a perfect relationship because they're the same thing. Height and height is a perfect relationship. You're going to see the same thing. We're looking for the relationship between weight and height. You can look at either one of these diagonal boxes because they're both on either side of the one. They're mirrored. They're exactly the same. So when we look at this, this gives you your Pearson's R value. When you guys interpret your findings, please put R equals so I know what it is that your value is. If you just put that value, I don't have the permissions per se, because I'm not the prof, to assume that that's your R value. You have to tell me that your Pearson's R is equal to 0.588. You have to tell me that your P value is less than 0.001. I will accept less than 0.05 as long as it's actually true to be less than 0.05. So if it comes out like this is less than 0.05 if you wanted to say that. As you go on through statistics, as you move into the upper years and go like maybe to grad school for some of you, it actually matters. For best practice, I would recommend putting this if you see this, because that's just what supervisors want. Yep.
For some of them, like the significance, it will say like a specific number instead of less than 1. Do we say the specific number as well?
So if it's significant, so if it's less than 0.05, you do not have to. I would just say it's less than 0.05. If it's bigger than 0.05, you can put it if you want, or I will accept the flip sign. So instead of the less than, it's greater than. Just make sure your sign is going the right way if you're not going to give me an absolute value in addition to your answer. If you gave me an absolute value and then gave me the wrong significance, like is versus isn't, I could give you a mark for having the right number. But if you don't, then you're going to be missing a component. Yep.
Is the shared variance on this table?
Shared variance is not on this table, but when you run your scatter plot, it will be.
Okay.
However, you're not required to report on it. You can put it in, you can take it out, it doesn't matter. There's not going to be any marks assigned for it, nor docked for not including it. However, you do need to address it in the interpretation. Not necessarily your, like the number, but what these findings implicate for shared variance. So essentially, when we interpret this, we know that there's a positive, moderate to strong, statistically significant relationship between weight and height when we control for the effects of physical fitness. This being significant, do I still have that up there? Yeah, I do. So weight and height, over here, this was our original correlation. It is statistically significant. this is exactly the same. This is what the relationship is when we control for the effect of physical fitness. These are basically like comparably the same. Obviously not exactly the same, but they're very, very close. They're still statistically significant, they're still positive, they are still moderate to strong relationships. So in saying that, your interpretation for the substantive part, the what does it mean part, is that when we extend the findings, we can say that, oh, well, when controlling for the effect of physical fitness, there was still a statistically significant strong to moderate relationship between, strong to moderate positive relationship between weight and height. We have reason to conclude that the relationship between weight and height is true. And we are able to conclude that the effect of physical education was not having an undue effect on the relationship. If this was non-significant, and like this was like completely backwards compared to what you had before, something has changed. The only thing that changes between your correlation and your partial correlation is that you're controlling for the effect of that third variable. So if it's completely backwards and it doesn't make any sense, what it says is that the particular effect that physical fitness had on weight and height was strong. It was having an undue influence on the relationship, and that particular set of variants was responsible for the original relationship that you found. So if it's the same, you could probably conclude that there is a relationship between the two variables. If it's different, it's likely that your third variable was responsible for a large proportion of that variable. Does that make sense? Well, yeah. Well, thank you guys for coming. I will continue to give rubrics in class. Yep.
Will this PowerPoint be on campus?
Yep. We're gonna post it probably later today. You guys will have access to that. I will continue to be showing up on tutorials. So like if you guys like my tutorials, you're welcome to hang out. If you don't, I get it. People have different learning styles. Like if you want to hang out with Fumi or Karina, they're great. They're just as qualified. But yeah. So I'm happy to answer any questions that you guys might have. There is another class in here after me. So at 11, if you need to go somewhere else, let me know. Hold on.